So today's workshop topic is AI and machine learning using Python. So before we start, I just want to understand what you understand, like what comes to your mind when you hear AI. Yeah, just any of you can answer, or one by one. Okay. Yeah, yeah.
Basically, I think AI is like a
Second,
second
yeah,
brain. I can
yeah,
keep it as second brain.
yeah.
Like
Perfect.
if my brain stop working, I just
You depend on
activate
AI.
this brain
Yeah,
and it does the rest of my job.
yeah. What about you? Do you think it's a replica of human? Yeah. Okay. Okay. So we just see the topics for today. We are just going to go in a brief introduction of AI and machine learning. We'll see few. We'll discuss. This is going to be more of a discussion, and it's fun for both parties. Then, if it's not a discussion, then we'll see introduction to sklearn. So sklearn is basically a scikit-learn, as you say, is the module that we will be using to create this AI models in using Python. So it's a built-in module in Python that already. So we'll discuss the main components that goes into building your own model. We'll see the very first step that is for important for any AI model or machine learning model is data. Nothing will work without data, right? Then we see types of models that will be covered in the first. So there are different algorithms present that you use to achieve these models. Then we see a few projects, what projects you'll be doing by the end of the course. Okay. And then why would you want to take up this course in the first place? Okay. So AI is basically what? Simulation of human intelligence in machines. So what is the goal that you're trying to achieve when you say, okay, you're training a model or giving some data and trying to create a new AI model, right? So you want your machine to be able to think, learn, and make decisions on their own, correct? Then the main goal is your machine or your model should be able to reason, should be able to learn, should have perception, and also problem solving. So we'll go through it one by one. So what do you mean by reasoning? And you, yeah. So basically, let's say if I give you some set of rules, okay? So like your signal, if you are stopped at a signal, the signal is red. Uh, so that means you need to stop your car. If it's yellow, then okay, you're getting ready to leave. Or if it's green, then you're supposed to leave. The machine should be able to decide, looking at the color of the signal, that what it's supposed to do. That's basically reasoning. Learning is self-explanatory. You're giving some data to the model. It should be able to learn and apply those data into different fields, right? Perception, what do you mean by perception? So perception is basically whatever information you're getting from your surroundings. So as humans, how do we perceive things? Through your senses. Like, yeah, you'll see, you'll touch things, you'll hear things. That's how you do. So how do you do that in a model? Something that's robotic. Any idea? Sensor, yeah. Yeah. What else? Cameras. Yeah, that can be one thing. Okay. So where do you think perception would be necessary? Like, if you want to discuss a real world example. Yeah, that is one. What else? Can you think of anything? We have self-driving cars now. For self-driving cars, definitely you need a lot of perception. You need to see what objects are there nearby, right? Then last is problem solving. It's of no use. Your model is of no use if it's not going to solve your problem. Okay, so based on the data, it needs to give you a solution. Now again, if you're stuck in traffic and you're getting late for a meeting, so what do you do? What options do you have? Either you can just sit there and wait. Either you try to find other things. If let's say some other local transport is nearby, then okay, maybe you park your car somewhere and go there, or you choose the alternate route that has less traffic. So as humans, we are able to, think of these alternate things and then solve the problem basically at hand. Then what are the examples of AI? So two are already mentioned, your Google Assistant and Siri. Okay, similar to Siri is like, yeah. What else can you think of? The most used one we already spoke about.
ChatGPT, Gemini.
ChatGPT, yeah, Gemini. Yeah. So there are different types of AI. Okay, so the type basically depends on two things. First thing is functionality. So what your model is doing, and next thing is capability. Okay, so how much is it providing? Okay, so based on functionality, the first one is reactive machines. Okay, you're giving some input, but it doesn't store that input anywhere. Okay, there it has no memory. It's not storing. You're giving input, immediately it's thinking of the best solution and giving you the output. Okay, so for one example is IBM's Deep Blue. Have you ever heard of that? Anyone into chess or anything? No?
Probably, but I don't know. One
Hmm.
podcast is
Okay.
IBM's.
So since you are not into chess or anything, but there was this grandmaster. Grandmaster is basically the highest level that you can achieve in chess. So there was a person called Kasparov. Gary Kasparov. Okay, so this is basically a AI or a computer for playing chess. Okay, so you have human opponents and this
Yeah,
is your
yeah.
computer. Yeah. So he was the grandmaster, and this model could defeat him. This was, I think, around not even it's not even new. It's this thing is around 1997 or something.
1980s.
So that time this AI could achieve that. It could beat the grandmaster. So that this model is basically it's not storing any memory. It sees the move, but it will calculate the best move possible. Okay? Then next is one that have limited memory. It can store short-term memory. So your self-driving car. So it has a short-term memory. It can memorize what objects are there only for the time being of you moving from point A to point B. It can memorize the signs, signals, all the driving signs. Then you have theory of mind. Again, theory of mind and self-aware AI is something that is theoretical. It's not present. So theory of mind is basically it can understand human emotions. Okay, right now you're typing it, even if you are angry, it's just programmed to say, okay, sorry, I'll just try a better solution or something. But it cannot actually understand what you're saying. Sure. Just keep. Then next is self-aware AI. How is it different from the previous one? That it has its own independent thinking. It can make its own decisions. We don't need to provide any input. Correct. It will have its own desires and everything. Again, this is in theory. Then based on capability, we have three types. The first one is narrow AI. That is going to perform only one single task. Now, if we take example of face recognition, it's only going to, yeah,
Because
yeah, it's just going to recognize your face. So any idea how this face recognition works? Ever heard of it? Or hmm. So the first thing your face recognize model is going to do is first it's going to try to check if there is a face. First thing is that. Then it's going to dissect all your features. Okay. So like how much distance is between your eyes and to your nose. It's going to calculate, and those of course it cannot see our image. Like computers cannot see it. Even though there is camera, it cannot see. It has to convert. By the end, everything is going to get converted into numbers by the end of it. So those distances and everything, it is going to perform some mathematical operations and store it as a number. So each person is going to have a unique number. So then it's that numbers are stored in the database or in its memory. Yeah. Okay. So then it's going to check if this face is present in the memory. So for face recognition,
So it's like bank,
yeah,
secure a vault.
yeah,
Sometimes they use like face recognition to check
yeah.
your eye.
Same way for fingerprints and all. Yeah. So it's going to check with your scanning your face. It'll do the calculations again. Then it will try to match it with what it already has. When you created that when you start the new iPhone or something, of course, first it scans and does all the calculation. So then it will check. If it matches, you'll be able to unlock your phone. If it doesn't, then you need to try again or maybe stop using someone else's phone. Then there is general AI that will be able to perform multiple tasks together. Okay. Again, this is still not possible because performing multiple tasks, then it's basically like you're a human. It's difficult to program such a AI model. Then there is super AI again theory. It can exceed our intelligence. Right? Yeah. Hello, the ones who are attending the workshop online, if you have any doubt, if you want to ask anything, just feel free to even raise your hand or unmute yourself and ask the question. Or you can message in chat. Are you still there, Richa and Vissal? Just message in chat if you can hear and are you able to see the screen. Okay, now we discussed so many things. Now what is necessary to build such a model? So the components of AI would be machine learning that we are going to anyways discuss in detail. So we'll come to that because major of the course is focused on machine learning. Then there is natural language processing, that is NLP. NL natural language processing meaning we are texting in, of course, different languages. English is just one of them, but there are different languages in what the user is going to interact with your model. So your model needs to be able to understand what that language is. Of course, again, it's not going to understand text values or what we are saying. So this is responsible for converting your language into, it will store it, whatever you're saying, it's going to split it into different words, different grammatical words, separately for grammar and separate, the other words will be separate. This will be stored in its database. It will try to check, convert it into numbers and try to check in the database that what are we trying to say. Again, convert it into the language and that's how it's able to perceive. Then we have computer vision. We discussed that through cameras and sensors. Then we have robotics. Robotics is what we are talking about is everything that AI is not physically able to change anything. If we want the AI to physically make changes, you need robotics as well. So this is basically your engineering plus AI. So where do you think would we need this robotics? One you already told me vacuuming and self-driving cars. Any other thing that you can think about?
Instead of waiters, they can just use robots.
Yeah,
And
right. Then
one of these.
in Japan?
Not in Japan, even somewhere in US, marine guys,
Okay, it's Europe.
yeah.
Oh, that's a yeah. Japan has a lot of places.
Japan
Very
is
common
like
there. Yeah. Have you seen anything like that? Yeah. Okay. Yeah. 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 So then you also have these surgical robots, very necessary to that. Yeah. you need physical interactions. Now, when we talk about surgical robots, that needs the next thing, expert systems. That robot has to be expert in that particular field to be able to perform that.
Trained.
Yeah, so you need expert systems. Even if you see the loan approval, this thing, there's not sitting behind and checking what's your CIBIL score and deciding, right? You already have these expert systems in place to analyze all your data, what's your score, how you're frequent, how are you at transactions, how many transactions you do. There's so much data that goes in, it will analyze that and then approve your loan. Okay. Then you have speech recognition, kind of similar to the NLP, but here we are doing text and speech. This is specifically for voice. So here how it works is it will analyze your sound wave when you're speaking. So you have these voice assistant and all. It will analyze the sound wave. It has already words stored for which it also has the sound waves. Then we'll try to match the sound waves and decide what are you trying to say. Of course, it's not always accurate. So when you're trying to text someone through voice and trying to convert it, sometimes of course there will be error. The sound waves can there could be similar sound waves for different words. So that's how those errors come. Sorry,
Google Translate.
Google Translate. Yeah, yeah, same thing. Yeah. Okay. Then now we'll discuss machine learning, which is the most important part of any AI model. So what do you mean by machine learning? Here you're basically providing a lot of data, large data set to your model and trying like asking your model to learn from it basically. Okay, so you have two options in machine learning. Either it can be supervised learning or unsupervised learning. So what do you mean by supervised learning? Supervised learning is basically you're providing the data also and you're providing the output also. So like if this is the data, this is what you need to provide as output, right? And unsupervised learning is you're just giving unlabeled data. So you're not going to provide any output. You're just going to give the data and your model is going to search for the patterns. Depending on if we take example of students, you're predicting how much marks a student is going to get. So what kind of data do you think would be necessary for that? What kind of data do we need to provide the model? Like first thing would be how many hours did they study? So can you think of more such things? Hmm.
Means you are trying to like how
Like
many
if I want my model to predict is the student going to pass or fail? Okay. So what kind of data do I need to provide to the model? The first example would be yeah. So one thing is how many hours. Then what else can you think of? Yeah, that's also there. Any other thing that could be important into deciding whether he's going to pass or fail? Hmm.
chapters which are the most important.
Yeah, so maybe if they did the yeah, yeah, the important this thing. But that would be very generalized, to give the sub.
Chapter 6 subject there are chapters.
Hmm.
But in chapter B is more percentage.
Yeah.
So we learn that this study routine.
Okay. Yeah, routine is a better this thing. So how much attendance maybe they have, how many practice questions they have solved. So all these data that you'll provide to the model. And let's say, like you said, if they've studied for 6 hours, then the probability, of course, is that this person will pass. Okay. So you give different values, you give the output also. In supervised learning, unsupervised learning, you're just giving the data. You're not going to say if the student is going to pass or fail. Then there is reinforcement learning. So how this works is it works on the basis of reward systems. So basically trial and error, like how we learn or how kids learn. You make a mistake, you of course no one does this now, but if you do something wrong, you're going to get a good slap. So you know you're not supposed to do this next time. If you do something very well, you score really good. Maybe they'll buy you something that you wanted, right? It's like a reward system. So you know, okay, you're supposed to do more of this. So this reinforcement learning is like that. So the most of the gaming AIs that you have work on this reward system. So this thing that you see, linear regression, decision trees, these are just the two examples of algorithms to you have to achieve supervised learning. Then for unsupervised learning, you have k-means and PSA. So these algorithms are what we are going to use in Python to build your own model. Okay. Applications in healthcare, disease prediction is one thing. Maybe you're predicting if someone is diabetic. So instead of humans trying to go through all the reports and everything, you feed in the data to your software, whichever software that the hospital or whatever is using. So based on the new data that is coming in, or based on the BMI or whatever, the blood sugar levels, your machine will be able to tell you if this person is diabetic or not. Finance, you can use it for fraud detection. E-commerce, product recommendation. Or you can give any other example for similar to e-commerce in. So I've already written it there for entertainment, that you get recommendations on Netflix and all. So how is it deciding what to show you based on your previous watch history? It's a learning. Yeah, yeah. So it's seeing what kind of movies that you're watching. It will see the genres, and then it will try to match with the similar genres and show it to you. Right? In education, you need personalized learning. Right? That is one thing. And transportation, we already saw. So these are just a few examples. Of course, it's not limited. Has a very vast range. It's not never ending. Okay. Advantages. It's going to reduce human effort. It can operate 24 by 7. It's not going to get tired. You're improving accuracy, right? And it can handle big data. If someone like us is going to sit and go through all the data and try to analyze everything, we'll go mad, definitely. But it's easier for your model to do that. Again, if there are advantages, there are going to be disadvantages. The cost is one thing. Then you require this big data thing that we're talking about is again also a problem. So if you're going to train your model only on a small amount of data set, we discussed this example of the student passing or failing. If I'm going to give only 5 or 6 examples or 5 or 6 combinations, if a completely different example comes in, it's not going to be able to predict if the student is going to pass or fail. Or if we take example of image recognition as well, let's say you're training the model to decide if the picture is of a dog or a cat, and if I show them only 5 pictures and I get a different looking dog that's not similar, doesn't have the colors that were present in the photos, it's not going to decide. So the data set has to be really large when you're training your machine learning model. Okay. It lacks creativity, cannot decide for itself, it won't be creative, and risk of unemployment that we have already seen. Okay, then the main topic for today, the module that we are going to learn in this course, that is sklearn, or it's also called scikit-learn. Okay, so that is a machine learning library of Python, and it's built on anyone familiar with data analysis? Of course, you won't have the, yeah. So data analysis, basically you're trying to summarize your data, trying to find patterns. So if you're working in a store, you would want to know during which like during which months there are maximum walk-ins. What is a product that is maximum selling? All that is data analysis. So for data analysis, you already have these built-in modules called NumPy, SciPy, Matplotlib. NumPy is basically working with numbers, okay, or numeric data analysis. SciPy, it's going to work with all the scientific calculations. Matplotlib, you need to generate your graphs and all of that. So this machine learning module is built on top of that. So it's using all these modules to create this module, scikit-learn. Okay. So why would you want to use this scikit-learn in the first place? It's easy to use, consistent API, very simple way of writing the code. Then it can handle supervised and unsupervised learning. So it already has a lot of functions and modules that are already present in this module that can do your supervised learning and unsupervised learning. So it has tools for model selection, evaluation. We'll come to this one by one. What is model selection, evaluation, and pre-processing? And it works seamlessly with this NumPy and Pandas. So why would you need this NumPy and Pandas for working with data? The first thing that you're going to do is provide data to your model. So these are the modules that you're going to use to create that data. Okay. So the major components is first thing is pre-processing. So now when you're giving the data, you can just not collect the data and just give it randomly. You need to check that data. Are there any missing values? Is the values consistent? Okay. Are there any duplicate values? Right? All these needs to be checked. If it's not there, you need to clean that data. For cleaning the data, you have this NumPy and Pandas module that you're going to use. And there are these modules you also have in scikit-learn, that is standard Scala. We are not going to focus on this. That's when you start with the coding. So these are just the examples. Then you have model selection. In model selection, what is that? If I'm giving 10 values to my machine learning model, I'm not going to use the entire complete 10 set, all the 10 values for training the model. I'm going to use maybe 7 to 8 values for training, and I'm going to keep the rest 3 values separately. Now, why is that? Because when you're testing the model, how well the model is working, it would be silly to use the values that you've used for training, because that it already knows, it has the answer for those values, right? So it's like I'm giving you questions and answers and I'm testing you on the same thing. But if I just give you the content, you don't know the questions, what's going to be there, right? Then maybe you might fail in some questions similar to that. So you're not supposed to train in the complete data set. You always take 80 to 70%, and then the rest you use for testing the model. Then supervised, unsupervised learning, we already saw. So there are different algorithms that you have. One is this logistic regression that you have for supervised learning, and k-means for unsupervised learning. So all these models work on some kind of statistics, or a lot of statistics that goes behind it to understand these patterns. Then you have metrics for analyzing how good your model is. So you have accuracy score. What do you understand by accuracy?
Well does a person know a particular subject?
Like if the answer is supposed to be yes, how many times has the model given me yes as an answer? Okay, so that is accuracy. Then there is something called as precision. So so kind of similar, but it's not the same. So how is precision different from accuracy? Precision means how many times consistently it's giving me the same results. Okay, consistency, and this is okay, it's giving me true values or not. So that's different thing. So there are more, so this is confusion matrix again for testing if it's giving true values, false negative, false positive, if you've heard of that. So this gives all those values. So you have to evaluate your model based on these values. If it's not fine, you need to make changes, use different kind of algorithms, train it again, test it again. You keep repeating this till you get a model that has a good accuracy. Then you have pipeline is basically your instead of doing separate steps, you're just going to combine everything into a one pipeline. So when you feed in the data, everything is done in one go and you get the output. Okay. Then the first thing that you need to do is data creation. So from where would you get your data? any Google Forms, Google surveys, sensors that you told, right? So all these things that you're going to do to collect your from different websites, but of course it has to be accurate, because if you're going to train the model with garbage values, it is going to give you garbage output. Then the next thing that we discuss is the pre-processing. You need to clean the data. Everything should be accurate. If it's you've done Python, right? So you know what is string, int, all of that. So basically, any character values are your string values. Okay, numerical values are called integers. Okay, so whatever is there in string is supposed to be as a string data type. Whatever is there as numbers is supposed to be in integer data type. So all that has to be accurate. And then you need labels for your data, basically the output. Okay, so what are these features that we are talking about is the data that you're using for training. Those are called features, are the input data that you give to the computer. So that example that we took of students will have hours studied, attendance, homework done, right? So these are the features. Now, these are just the two examples, but you'll give a lot of data like this, right? And label is going to be your output. What result are you getting? Is it is the student passing or failing, right? So labels is answers to the answers or output to your, yeah. Okay. So for example, if you're checking if an email is spam, so what kind of data would you provide for checking? Yeah, sender, but you need to give words that you think would be in a spam email, right? Not the entire content, but more frequently occurring words that would be in a spam email. Like spam email would be something like win a lottery or win something. So those words that keep reoccurring in spam emails, that you need to train your model on those words. Okay, so for that the label would be spam and not spam. So these are the different supervised learning algorithms. You have logistic regression, random forest, decision trees, k nearest neighbors, naive Bayes. The difference is the statistics that goes behind it. So in supervised learning, there are two types of supervised learning. One is classification and another one is regression. So what is the difference? In classification, you will get that yes and no answer, or pass or fail, spam or not spam. In regression, it's a continuous value that you're getting. You'll get, like if you're predicting how much this house will cost, right? So that is going to be a numeric value. For numerical values, you need to use the regression models. For unsupervised learning, again, the example is k-means clustering. So grouping customers based on their spending habit. So what would be the example of this? What kind of, like what clusters would you form if you're taking an e-commerce website like Amazon or something? Based on their spending habits. So someone who's more into spending habit, as in what kind of products are they buying more? Yeah, depending on that. Or if, are they more into electronics or something like that? Yeah, it and all these websites do have access to which product you're clicking on and all of that. Okay, so that's how it recommends. So we'll just do a small this thing activity. I'll just show you a few topics, and you just write down what features or labels would be there for that topic. Just give me a minute. Prediction. Then you could do on e-commerce or and some entertainment based, maybe Netflix or something like that. But
What exactly? Yeah.
so you need to write in the features. What kind of features would you provide the model to train it, and what kind of labels would be there? So, like we took the example of students. So you had to study arts, right? So what leads up to getting that output and the output itself. So you need to decide what features would you like to update. So you also need the output. Or if you are taking cities like that, maybe traffic, like going from point A to B, the model has to predict how much time it will take.
Time.
So what, yeah. So what kind of features do you use there? Yeah, you have a, yeah. Hi, do you have any doubt? Uh, could you tell me what kind of features would you take for training the model based on a disease if it's going to predict if the patient is diabetic or not diabetic? Hello? Can you at least try? You've understood what are features and labels. So you can write down for multiple diseases. For different diseases, there would be different this thing, right? One was disease, the other one, if you want to try, then you can take the entertainment one, or you can try for a different disease because for every disease, the features is going to change. Hmm. Yeah, yeah,
like what is it, action, horror, or sci-fi?
yeah,
That
yeah. That also. Even watch time would be a thing. Yeah, for healthcare disease prediction, what kind of data would you use to train the model? So if we talk about diabetes, what data would you need to train the model for the model to decide if it's going to be a diabetic person? What else can we, their blood sugar level, their BMI, their age? So the body checkup, you need to provide the values, right? If you're saying body checkup and body checkup, what will it involve? It's going to uh, analyze your blood and tell you how many platelets and all are there, what is the blood sugar level, what is the BMI. So all that data you need to provide. So those are your features. Done. The labels. So what are the out? What is the output going to be? You will have a lot of different this thing outputs. Hmm.
there would be the
Yeah, yeah, yeah. You done? Can you just read out yours? Hmm. Okay. Yeah. Hmm. You got that? Or you weren't able to hear? So she is written for malaria. The features would be fevers, chill, fatigue, pain, and joints. So if all this is there, then the labels are malaria positive or malaria negative. So that is two outputs that you're going to get. For diabetes, it's fasting blood sugar level. Then after meal, what is the blood sugar? For diabetes, also you can add their age, BMI, and all that. Okay? The more features you give, it is the better. It can analyze it better. And labels are again either they have diabetes or positive or negative. So your labels are going to not be just, so I told you there are two different types of models, right? One is classification and the other one is regression, where you have continuous numbers. You're not predicting either it's yes or no. Even yours is not either a yes or no answer. There are multiple outputs. Yeah. So that they are going to predict different numbers. So if you are going from point A to point B, what have you written in features? Yeah. Yeah, conditions. Yeah. Then you can check for are there any accidents currently or not. So your Google Maps and all does what it's going. It has some previous values that it already knows. Okay, at this time the traffic is no matter what the location is, but at this time there is more rush. Then it has constant live feed also. Wherever there are accidents happening or there's some construction work, it even if when you're using Google Maps, it does ask you, is it the congestion still there or not, right? So it's taking live input also. And from using GPS, again, it's also tracking the at one particular area how many vehicles are present, right? So all that it's using. So all those are your features, which is going to give you an output. Again, that's going to be a continuous value. So this is your labels is your ETA, basically what you get from point A to point B. And what have you written?
It is search history
Yeah,
for the person life. Then comes the genre. Then the option they want to watch like the trailers or the whole movie. So
yeah,
when I've done like age specific, so I'm making a
yeah,
childhood so
yeah.
cartoons and if it's
Right,
like
right.
18 plus adults in that.
Yeah.
And even the language, so like which language, so
Yeah,
language.
that is also there. Right, right. So based on the language, it's going to show you more of movies and series that are based on those languages. And same with the age. So good thing on age and this thing. Yeah. So you're getting the idea of how you're going to choose your data to train it. Now, again, it's very important what features that you give. So let's say I'm predicting house prices. So for house price, what would I need? The area, how much area, carpet area? What is the location? Is it a new building, old building? What is there nearby? Are there any facilities? Right? What else would you need for?
How far does that reach beyond other platforms of social that what
Hmm.
price was that so
Yeah, that is also helpful. But if when you go to search the data, you'll have so many more this thing like what color the house is, what floor it is. Floor, maybe floor also does affect the price. Yeah, but if it's color or something like that, that data is useless to your model. Yeah, yeah. So your features will also have different weightage. So which feature is maximum has maximum effect on your output? Now, if we discuss this, you said the location is going to be the main this thing is that is going to decide the price, right? In yours, what do you think would be the most important one? Yeah, yeah. Only one person is there.
I guess each
Age.
different
Hmm.
region, previous source history,
Would age be more important than John?
or a language,
Yeah, languages.
language.
And for yours, if we are speaking about diabetes, which is the most this thing uh, that is going to affect your output out of all these? Sorry, for diabetes. Yeah, blood sugar level. Right. So now, how would your uh, machine be able to understand which is more important? So it does all those correlation calculation. So based on the values, it will perform some statistical analysis. It will see which one is affecting more to the output. Based on that, it's going to give higher weights. Higher weights meaning it's going to have more bias towards those features that is going to decide the output. So we'll just discuss this one model one algorithm for classification. So that is your logistic regression. This is one algorithm that you can use to train your model. So this, I don't know how many of you are familiar with statistics or maths in general. Weak,
We are
yeah,
not.
aware of done statistics. What about you? Seven. So you do you know what is linear regression? Have you heard of linear regression?
Neither.
Yeah,
Yeah.
that is just your normal graph that you use to find the line fitting, right? The straight line fitting. So this logistic regression uses linear regression and something called a sigmoid function. So don't worry about the sigmoid function. First, it will calculate the linear regression. What is the formula for that? Y equal to mx plus c, if you could recollect a little bit, right? So you're getting what is y here? Y is the output that you're getting, right? Mx, M is your weightage that you said, whichever one feature is more important, that will have a more weightage. So it's going to apply more higher value. So let's say if you are talking about this thing, you said what is important, the language. So when language you take it as a feature, X is your feature. Okay, Y is your output, X is your feature, M is the weightage that we are talking about. So if it has a higher weightage, it will multiply it with a higher value. So it holds more importance. Okay, plus C is just your constant value. Okay, it's going to first calculate that and then it will apply the sigmoid function. Sigmoid function is basically reducing whatever value that you got between 0 and 1. Okay, it's because you just need two things, right? Either it's going to be a yes answer or a no answer, diabetic, not diabetic. Okay, and for regression, is because this is for the classification model, so it's just going to have two outputs, either yes or no. So you cannot have numbers between this range. Either the output has to be 0 or 1. So the sigmoid function is responsible to converting all your calculations to either 0 or 1. So if it's 0, the student has passed. If it's 0, they have failed, and if it's 1, they have passed. So this, after applying the sigmoid function, this is something that your graph looks like. Okay, it starts from 0, ends at 1, your y-axis, and this is the sigmoid curve. So all the values that will fall here, whereas y is equal to 1, so that the student is going to pass. And all the values that are coming down, that means the student will fail. So this is a very like overview of how this model works, because when once you start coding, you need to understand in depth how this model is working. Writing the code is the easy part, but then how it's working is more important. Okay, so these are of course you can choose more projects, but these are some of the projects that you'll be able to do by the end of the course. One is spam email detection. Okay, this is one model. You can create also a chatbot. Even your chatbot works on a similar basis. It has been trained with a few question and answers. Of course, not like ChatGPT. ChatGPT is a completely different. So that ChatGPT again, it uses all the data that all the possible data that is present on the web. It will study patterns from that and give you the output. We don't have such a large data set. Of course, it's going to be a simple chatbot, but it works on the similar ML based model. Then disease prediction, we discussed that, right? Language translation. How do you translate from one language to another? For this also you again need ML. Then you have all these personality type prediction. You have all these online websites that you fill in some form and it's able to detect your personality, right? Then ETA prediction that you did from point A to point B, what is the ETA going to be? So you can also choose your own project. If you have a particular topic that you want to do, then we can focus on that project. So you'll be doing that project by then. Okay. Now, why would you want to do this course? So the first thing is it's not like I am saying and you're doing nothing. You're going to do hands-on coding. Because right now, as part of the workshop, we cannot focus on coding because some of them don't have the coding background and that becomes difficult. So you'll be doing many projects and everything step by step that we discussed, data creation, pre-processing, how to train the model, all that code one by one. Of course, first we are going to do the topic and then you are going to practice that code. Then again, it's beginner friendly. We are not going to go into such high level ML and machine learning because, of course, that becomes very difficult and that's a lot of statistics also that is involved. Then, of course, industry level skills, all these NumPy, Pandas, the modules that we saw, and also the Scikit module is used worldwide. So that becomes a plus. Then it's of course, career boosting course. You can show all these projects that you do on your resume or LinkedIn or wherever you go. And if you want to get into machine learning or AI as a career, this becomes like your foundation. Like if you do this course, you'll also get an understanding of is this something that you want to go ahead with as a career. And talking about career, we discussed this before you came. It's a very vast field. It's going to replace all other fields as well. There's no field where AI is not useful, right? So this is the biggest thing. So okay, do you have any questions for me? Hi, Vishal, do you have any questions, any doubts? Okay, so I'll just show you one example of the project that we have. So, have you heard of VS Code before? Have you worked with VS Code? You must have. You've done Python, right? So this is just a software for running all your programs. Yeah, with ChatGPT code. So again, when he came, he showed me built an entire app using just ChatGPT. Yeah, so that's how useful AI is.
That's what I guess.
So he created an entire application just with ChatGPT, no knowledge of any coding or anything. So that's how useful this AI is, right?
No, I didn't use it. So I
No.
just asked ChatGPT give me the prompts and I never built it. If anyone would ask, I just put the prompt in it and just build me an app in like
Yeah. So there's so much you don't even need the background knowledge of
even
coding to
everything
build all these
is just
application
AI.
AI. Yeah.
Then
Yeah.
again,
Yeah. I think you told.
yeah,
Yeah.
he takes like business AI companies agreements
Yeah.
and then sell them.
So the use of AI is endless. You could do anything with it, given that you know how to use it. Okay, so this is one of the projects that is disease prediction. So you're also going to learn how to create the graphical user interface. So if I run this code, Just take some time for this thing to come up. So this is what is the graphical user interface. So for this also you have a different module to create this window and how to place all these labels, how to get all these text box and everything. So this is part of your course. So now this project that I showed you is for disease prediction. Okay, we've given some values. So if you see, the first one is for age, second is their blood sugar levels, the last one is their BMI. So we've given different options with different age group, different blood sugar levels that we've trained the model. If we check the model, we've used logistic regression. Okay. So now based on this, for those who have done Python, if you know your normal if else conditions, right? So you think how is it different from that? Because I could give this values right in my if else conditions as well. I'll say if the age is this, the blood sugar level is this, and this is the BMI, then you show me this person is diabetic, right? But for that, for you have not, you heard of if else? So there's something called as conditional statements where you give all these conditions beforehand and it gives you output based on the conditions. So there you have to hard code your conditions, right? Now if given 25, 90 and 22. So I'll need a if statement for this for all these values. If I put a different value, will it be able to detect that? Sorry? Not for this, for your normal if else, without the logistic model. No, for if else you need an exact match, right? If I say if number is equal to 25, if only if I enter 25, it's going to give me an output. If I put any other number, it's not going to, yeah. Right? So that is the difference here. Here your model is going to learn from this. So let's say if the blood sugar is increasing, it knows, okay, when the blood sugar increases, this person is supposed to be diabetic. So all these patterns it generates on its own. So now if you want to try and enter some values like enter age and then click on predict disease, you can add, yeah, yeah,
Done.
it's showing diabetic. Of course, this person, they are also obese and also have a high blood sugar level. So that will be a diabetic person. So it's able to gauge that. Now, if I check the values here, the age you kept was 22, right? So we don't have any value here for 22. That's a completely new value. Okay, 150 we have, and okay, there is no 50 BMI as well. Okay, so it's able to predict based on new values if, whether this person will be diabetic or not. Okay, so this is one example of one project that is there. Like that, we have different this simple chatbot that I told you about. Then even customer prediction, how the new customer is going to be based on their spending, how what kind of products they are buying, right? Then you have spam email detection, whether this email is spam or not spam. Then traffic prediction. So for all of these, you have this GUI where you can enter new numbers. It's going to predict what the output is going to be. So now all these use different models. It's not going to be just logistic. It's some have to be regression, classification, and in that also different algorithms. Then you check if the model is working correctly. So we saw those accuracy matrix, right? Confusion matrix, precision. These are just three examples, and those three are also for classification. Okay. So if it doesn't give you a proper accuracy, you train the model again with different data. You change the model, you see the evaluation again, And once you have a satisfactory result with the evaluation, then you move ahead with the pipeline. So that was all. Do you have any questions or anything? Okay, that's all for the workshop. Just a minute. Hi, Vishal, do you have any questions? Any doubts? Did you see the project? Hello. You understood the project? Were you able to see the GUI and how we got the output? You have any questions? Okay, thank you. So that's all for your workshop. All the topics that are included has been shown. So how your flow would go, we'll be teaching you one topic and then you would be practicing that topic. You'll code for that topic. We'll move on to the next topic and code the that part. And by the end of the course, you'll be doing one of these projects. Okay. Thank you. I ask them to leave first. You want to? Sorry. So it's a 20-hour course. So if you finish learning everything, you can do multiple. Also, it's not that we are sticking to these topics only for your projects. If you have your own topic, some model that you want to build, then we can work it out that way. Then you will be working on that project. You have any questions? Okay, so this is your, no, it's there, your, yeah. So this is all the topics that we'll be covering. So I told you you need NumPy pandas for creating your data, right? So first we are going to just go through the overview of NumPys and pandas, how to create those data sets. So this is all introduction to NumPy, pandas, how to create data frames and all of that. Then you have the machine learning module. So first is your introduction steps and to train your model, data creation, features and labels. How do you code for that? Then data pre-processing. For pre-processing, we use the pandas and NumPy model. Then you have data scaling and normalization. Basically, if for different features that you told me, the values could be really high or low. Some is between the range of 1 to 10, the other is between 1 to 10,000. So what your model is going to think that the values that are from 1 to 10,000 are more important because it's a higher value. So you need to scale down your data. Everything has to be in a similar scale. So like if one column is between 1 to 10, even the others have to be between that range. So that is your data scaling. Then encoding and feature extraction. Again, your machine is not going to understand any text values. So whatever training also you do, you need to do on numerical values. But when you collect the data, you're going to, of course, have characters, string values. So for that, you need this encoding and feature extraction. Then we also discuss the training and splitting. You need to split your data. So that is one part. Then you have supervised learning models. So there are again two things, classification and regression. For classification and regression, you have different algorithms that you're going to learn. For regression, again, you have different algorithm and even for unsupervised learning. Then how do you evaluate those models? The last topic would be your GUI, how to create this user interface. And then finally the project, combining everything together. Okay. So So for every topic, we have already notes and everything, different examples for each topic, like 4 to 5 examples for every topic, detailed notes for each topic. So if you see supervised logistic regression, unsupervised learning, those models, train split, evaluation, feature extraction. Feature extraction was the converting your text into numbers. So for all of that, we have detailed notes that you will be getting once you enroll one by one. When we finish the topic, by the end of the topic, you'll also have these notes with you.